Hey guys, welcome back. It's been a while since I did my last video, so I wanted to show you what I've been working on since then. I started to look at my robot tank project from last fall. Was it fall? Yeah, I guess it was fall. And I realized that if I wanted to redo that and make it more stable and, just tougher, I would be looking at a pretty expensive project, right? The wheelchair motors, all the control electronics I already have. Found somebody similar, did a similar project, and he had about $1,500 into mostly the frame, some 80/20 aluminum plates, and totally stuff that I could have put together and worked with here, but it seemed a little bit expensive. And another thing that I realized last summer working with the wheelchair robot, it was very tough to work with in the shop. I had to wait for a nice day to take it outside. The rest of the time I'm just kind of in the garage tinkering away on the software. So I wanted to downsize the whole project a little bit. I started looking on Thingiverse for some tank projects. There's a couple of commercial projects out there. The Wagyu Thumper, the T-Rex are some of the six-wheel and tank chassis projects that are out there. They were a little bit small, and I didn't really know how I was going to build on all of the electronics that I wanted and hold bigger batteries and things like that. So eventually I found this project on Thingiverse, a guy named FastMike. He made a series of things, and it's basically a fully functional tank platform. It's a set of aluminum rails that are you can pick up the material from Home Depot or Lowe's, and then tons of 3D printing and tons of hardware to go with it. So let's take a look at how I built one from his projects, and I'll just give some commentary as we go. And okay, lots of 3D printing on this project. About 50 hours of printing, I think, and maybe even a little bit more than that by the time I figure all of the track links in as well. So I used 3 different types of plastics. Anything that you see in the project that's green is going to be PETG. That is entirely used for the tank tracks. It's a very strong material, but you can print without warping like ABS does. So I was able to print large trays. So I think I was doing 8 links at a time. Anything that you see that is blue is ABS. So it looks like all of the suspension parts, the sprockets for drive and tensioner, and some of the trim also blue. Then anything that's black, the idler wheels and some of the battery holders and trim and the grousser bars, those are all PLA. So lots of printing, lots of support that I had to use. So then lots of chipping support material off with the track links. We'll see later. Lots of post-processing there to clean those up. But overall, a pretty fun project to watch, come off the printer. So here we are, just finishing up a. Looks like this is one of the pieces for the worm gear covers. All right, so next we're going to look at the frame. Frame is 1/8 inch aluminum. It's I think 1.25 wide. I picked it up at Lowe's, and I wasn't quite comfortable putting one of these into my mill just yet and referencing off the edges and being totally confident that it was squared. So I decided to go a little bit old school. I got some Dykem, and that's the blue that you see on the metal here. You paint that on, and then you can scribe and scratch into the blue and not the actual metal. So I just referencing the cut sheets that he provides, a series of PDFs, went around and marked all of the hole positions and center punched them. Definitely make sure that you look at all of the PDFs that he has before you really get going. There's a few different updates, and there's a couple of variations to the frame rails and some of the support members, depending on which gearboxes and which actual idlers and parts you use. So just make sure you read through all of the things. Like I said, there's about 10 things that he put together. Really try to understand each part of that and how they play together before you get into this. I think on these frame rails for the side, I actually had to re-drill because I was using the 3D printed case for the RF006 worm gears that he provides. I think on the first thing that's labeled just tank parts, that had a slightly different motor mount to it. So here we are on the mill. There's kind of a complex cut or a pocket on the piece that the two motors mount onto. So this lets you have different size gears, and then the motor can swing in and out to accommodate the spur and the pinion sizes. I did all of the drilling on here by hand, so I had a couple of reference points to set the mill up on, and then I just went ahead and cut these pockets out. You'll see a little bit of coolant in a spray bottle, just an air sprayer right there cleaning out the chips, and there we are. A little bit of filing. I've since picked up a deburring tool, which probably make that just a little bit easier. And probably get a beer, back to filing. This is actually one of the first pieces that I had noticed that he sells on his eBay store. So he sells a full frame kit. But originally when I found him, he had the motor panel and the rear panel. And then it was sort of still a do-it-yourself side rail for the frames. The kits and the motor plate, all CNC'd that he provides, they look really, really great. Definitely going to pick one of those up as I get more into it. I think... a couple of my hand-drilled holes, hand-marked holes, might be off a millimeter here or there, some fraction of. So anyway, here's what it looks like with all of the frame rails drilled out and most of the 3D printed parts for the suspension and drive sort of all laid out. So we're going to take a little walk through assembling that next. See Helper Dan there. Angle brackets from Home Depot, and I had most of the hardware on hand for the frame itself. I think I just used a bunch of M4 or M5 hex screws. See a little bit of Loctite there. So here we are. We got the side rails, 2 support members, putting the motor plate on now. And then on top of the motor plate there are a couple of 3D printed parts, and those are what are going to mount the Sabertooth motor driver. So we see all of the plastic case for that here. Just wandering around trying to get the right screws, it looks like. Motor screws, I think 3mm is what I wound up using. We'll see the motors here soon. We've got a switch bracket there, and then we're adding the motor driver now. The plans I got for the back plate also did not account for the 3D printed worm gear covers, so I had to re-drill those. So now that's done. Put that back together. Pull it off. Throw the motors in there. Alright, so meanwhile, I had printed hundreds and hundreds, well, not hundreds and hundreds, but I guess about 100 track links. Each one have to file, drill. Originally, I started printing them with a brim, so I had to peel the brim off. And here's sort of the first run of track, just test fitting it and seeing how it works. The pins they use are actually just finish nails. I think it calls for 1.5 inches and then cut off just the 1/4 inch that's sticking out. I had about half of those that I needed on hand and tried them out. They were a little bit long and cutting them off was a little tedious. I found 1.25 inches worked fine. So just going through here and extending my first piece of test track, making sure I like the process and I'm familiar with it before we go into full-on factory mode. So this is rolling out all the pinholes, the track links, being various size, information, size, all that stuff. He was pretty meticulous in the documentation. I've got to give it to him. And anytime I have problems, he's helpful enough to get me going. But not so much to take away joy and surprise. That was at each corner of the project. Next we need to trim all of the brim and a little bit around the joint and the hinge there. So just an X-Acto knife and trimming that up. I tried to file the inside and outside edges where the drill went through. The PETG would just leave a little melty tail as the drill went in and out, so just a little bit of extra cleanup time there. I've also since then adjusted my extrusion feed flow rate a little bit. So I think I would have a little bit less cleanup if I were to do this all over again. This literally took me days. I think the tracks, the printing, I would start a tray of 8 tracks before I went to work. After I got home from work, sometime in the evening, hopefully one more before I went to bed. And then, you know, that was several days of that. And sometimes I'd wake up and it would have gotten halfway through and stopped for whatever reason, or maybe 1 or 2 popped off, curled edge here and there. Okay, so I come back to it and it looks like I'm just finishing it up and pinning. Took a break to put together the worm drive cases. Pretty good pictures of that already, so I didn't really get too much into it. Next, we are going to add the wheels, idler wheels, suspension. So, got a box of shoulder bolts on Amazon, made this pretty easy. Lots of support material for the wheels. We're just kind of dry fitting a couple there. So there's the dry fit. Here is everything we need to actually assemble. All the bearings, and here's what the support looks like for, I guess, 1 or 2 wheels. Pictures of suspension, and then we get it together and it looks something like this. So this is still pretty loose. I haven't put together the front end idlers here, but I got it together enough to make a quick video of it running. You can kind of see real quick there some of the DIY idler stuff I was working on. I've since got the suspension arms from his kit and have been able to finish that part up. Here it is, guys. So the suspension off of a buggy, some sort of 1/16 scale RC truck, I guess. All of the wheels, drive wheel, the worm gears underneath these covers, motor drivers under here, and I have a little power distribution board in there. Nothing else in it just yet. I'm gonna do some final driving tests tomorrow before I start to package it up. But I will basically be using these little pigtail wires here. These 2 wires I can plug into either my RC receiver or into my Navio Raspberry Pi shield. So I'm going to build a double deck on top of here. So it'll be batteries and then another plate, and then I will start to mount my computer electronics. So Raspberry Pi, probably the Xbox Connect, and some distance sensors and things like that. Awesome. Well, if you guys haven't subscribed to the channel yet, please click that button. Leave us some comments if you like what you see, and check back as we get this bad boy out, tearing up some dirt. Thanks for watching, guys.